Welcome back. I almost want to laugh again. Another video in my arithmetic and geometric progressions playlist. Here we go. Sum to infinity. What can add to infinity? And what do we mean sum to infinity? If I've got the numbers and I was adding, for example, 2 plus 4 plus 8 plus 16, so I'm doubling each time, that's just going to get bigger and bigger and bigger, and it's going to go on bigger and bigger. There's no limit, there's no end to it getting bigger. So it just can continuously keep getting bigger and bigger and bigger. But if you start with halving, so let's say I started with, I don't know, let's go with 16, and I halved it and I got 8, and I halved it and I got 4, and I halved it and got 2. You start seeing pretty quickly that what you're adding, I'm going nuts while I'm talking, what you're adding is getting smaller and smaller, and really much past there it's not going to add much. So if you did keep going, you get 1 on 64 and 1 on 128, and you're getting the very small numbers you're adding. So it'd be nice if we had a formula that did all of that for us, so we didn't have to go and add up all the numbers. So here we go. The original formula for the sum of a GP, now we're talking about GPs, if you keep adding 2 plus 3 plus 4 plus 5, you're getting bigger. There's no limit to it. It just keeps going. So we're talking about a GP, and there's our original formula for sum of a GP. I've got other videos if you want to watch on that. But let's have a look at this little bit here. If you've got a fraction, for example, say your R turns out like the first question over here to be a half, you've got this little bit that says 1 minus, and you've got a half. Sorry, I thought someone was coming to the door. 1 minus, and the ratio half, and you're going to keep multiplying that. So let's say we even made that 10. You've got 1 minus a half by a half by a half 10 times. Now I can tell you that's 1 minus 1 on 1024 because I know it off by heart. If it said 20, it's 1 minus 1 on, I'm going to go rough, about 1 million. So by then we're talking about a lot of decimal places. So in other words, this part here is becoming very, very small. And if you wanted to go further, if you made 30, you're talking about 1 on about 1 billion. If you make it 40, and what's happening is this becomes so small that it doesn't count. And we talk about that's got a limit of 0. So what happens, this part here becomes 0, and when you go 1 minus 0, you've just got 1. So that's why this just turns into 1/8 on that. So they're basically the same formula. And you could actually go through and use that formula and muck around with it and see what happened. But it's more time consuming and slow. Let's have a quick look at this. I've basically almost done that question. So the sum to infinity is a on 1 minus half. So the interesting part, if you're allowed to use your class pad calculator like we have in Western Australia, is you put the numbers in and you drag the table down and you soon see what the limit is. You can actually get this question very easily. I do like to muck around a bit. Okay, that's 150 plus 25 is 175. A half of that, oh by the way, I didn't say, obviously we're timesing by a half. So that makes it a GP, and we're timesing by a half again. We're talking about GP. And so therefore we've got R equals a half. So a half of 25 is 12.5, so then that'd be up to 187.5. And I'm adding on less each time. From probably a common sense approach, you soon see that that's going to go to 200. Wouldn't take long calculating. Let's do the actual calculation. A is the first term, that's 100 on 1 minus a half. And of course I do this one on purpose first because the numbers are so simple. 100 on 1 minus a half is a half. How do you divide fractions? Invert and multiply. So turn the bottom upside down and turn in a multiply, and there's your 200. And you can pretty quickly see what's going on, that would become 200. So when it's a half, it's a nice, because you're just going to double the first number. So what happens though if it's not a half? Let's have a look at it. I've tried to make it a little bit terrible without too bad. So R is the second term on the first term. So say you don't understand, you want to get some marks and you weren't confident, or you're running out of time in an assessment, you can put 90 over 100. And most people know to cross out the zeros, 1 0 on the top, 1 on the bottom. You've got 9/10. Let's have a look what happens with our formula now. The sum to infinity starting with 100 still. So we've got A on 1 minus R. So we're still going to start with 100, but you've got 1 minus 9/10. Now, I probably should even pick a worse example because this one doesn't turn out to be too bad. How many people watching know that 1 minus 9/10 is just 1/10? Of course, you can go 10/10 minus 9/10 is 1/10. But most people see it in their head. Interesting part then, because that's 1/10, and we invert and multiply because we're dividing, that's 100 times 10 on 1, and you get 1,000. So you can imagine how bad it becomes when you have numbers like a quarter or a fifth, and you're ending up with revolting fractions that work through. But that's enough for now. Thanks for watching. I hope you're enjoying it. If you do, if you want to press like, that would be helpful. See you in the future.